global community, about 66, almost 67 blockchain groups all over the world. And the idea is to create a global network of professionals interested in, like learning, networking, collaborating, sharing, and also advancing technology. So in fact, we do have a group in Shanghai, several groups in China as well, since, I heard, Shenzhen is from Shanghai. Now, these are some of the things we have done in the last few years since the launch of the blockchain program back in 2018. As you can see, we've been consistently organizing events every year since 2018. We have several educational modules. You can check it out. And also we have 25 published standards and some use cases like blockchain and energy. So check out our website. There's actually a tab for each one of these topics, like, community, there's a tab, events, there's a tab, education, there's a tab, standards, and so on. Here, this is what we did last year. As you can see, these groups I just talked about, right? These 67 blockchain local groups all over the world, they are very active. As you can see here, we have events. Well, we had events ranging from Toronto to Shanghai, Bangalore, Seoul, San Jose, Silicon Valley, Tokyo, Kyiv. That was virtual. Taipei, York in the UK. Tunisia, Africa, almost like about 10 events. And in this year, you can see we have over 25 events, very active community. I mean, we are directly involved, like as a financial or technical co-sponsor, and we also work with other events organized by, for example, you can see like University of York, Oxford, Princeton, and so on. We do partner with them as a knowledge partner, and at the bottom you see events organized by local groups and regional events. Regional events meaning, like, for example, in India, we have multiple groups in India, like about 5 of them in different cities. They come together and organize a much larger event. That's what we call as a regional event, and in this case, it's called the IEEE India Blockchain Forum. Okay, then here is a summary of list of 25 standards published by IEEE related to blockchain, distributed ledger technologies, and cryptocurrencies, and so on. Okay, that was the a 4-minute intro about blockchain technical community. Now let's get into the some of these topics here. This is the outline. So we'll start with introduction. And then we'll get into public blockchains, and then also we'll touch upon the metaverse topic. Okay, so now Bitcoin was launched back in 2019. Sorry, I said 2009. And it was basically a white paper that was published by an anonymous person. And one second. I have to close the window. And then the code was launched, the white paper was launched around like end of 2008, and then the actual code was launched in 2009. And actually that it set the stage. If you look at the white paper, so the white paper talks about a chain of blocks, which is basically it's called as blockchain nowadays. By the way, is the camera not working now? You can't see the video. So now I'll continue. So it's called blockchain 1.0, where Bitcoin and several other currencies were launched around this time. And that stage, basically that set the stage for the launch of what we call as blockchain. Now, around 2015, several blockchains such as Ethereum and Corda and Hyperledger were launched, and that basically what we refer to as the programmable chains or blockchain 2.0. And then later on, blockchain 3.0 refers to several architectures that were launched to address the scalability, interoperability issues, and there were also several DAG architectures, directed acyclic graph. And this slide shows the some of the ideas that have been innovations and experimentations in this space. And you can see the acronyms at the bottom, what it means, like Bitcoin was launched in 2009, and then stable coins were launched around 2015. And Ethereum was launched around the same year. And Ethereum, being a programmable chain, it enabled several ideas and concepts such as DAO and DeFi, NFTs, and then also games and Metaverse and so on. So let's step back and look at what these terminologies mean before we get into the details. So basically, we are talking about a computer network where we have interconnected computing devices referred to as nodes that can exchange data and share resources with each other. And distributed computer network is basically a subfield of computer network where these nodes they behave in a coherent fashion, so that way for the user it appears as a single computer. So now distributed database is basically as a database type of database that is implemented on a distributed computer network. And now let's talk about DLT. So DLT stands for distributed ledger technology, which is basically a type of distributed database. And now, so these are the three terminologies that you have to remember before we start talking about blockchain and DAG. So now blockchain and DAG, you can see that what DAG means. DAG is basically a directed acyclic graph. So these two are subtypes of DLT. So if you look on the next slide, you can see the relationship between these three terminologies. So we have the DLT, and blockchain is a subtype, and then we have DAG, which is also another type of DLT. So you can see the definition here. So DLT refers to a broad category of distributed database architectures shared among multiple participants, and they're updatable through a consensus mechanism. So we'll talk about these concepts very shortly, meaning these particularly the consensus mechanism. Okay, so this slide shows the data structure of blockchain and DAG. So blockchain is a linear data structure where each box you see here is we call it as a block, a batch of transactions, and the blocks are linked to each other through cryptographic hashing. And blockchain is a linear data structure, whereas DAG, directed acyclic graph, you can see it's kind of a crisscross kind of linking of these nodes. We call nodes, which are vertices, so which could be a single transaction, or it could be actually a batch of transactions. Now, this slide shows a simple architecture to understand the blockchain and DLT. So now the entire thing we're talking about, if you go back all the way here, see, we talked about distributed computer network. So DLT is on a distributed computer network. So that's why we have that as the first layer. In light pink color, we have the distributed computer network, and on top of it, we have this ledger we talked about, which is basically a distributed ledger, and the consensus protocol. Okay, so now the consensus, these are two important concepts. You can see the some definitions here. So the ledger represents the conceptual layer where transactions are stored in the network, and the consensus protocol defines the rules and parameters by which transactions are processed or approved by the validators in the network. Now, let's just remember the color. The ledger we use is the blue color, and consensus protocol we use like a light green color, right? So let's use the same, we use the same color scheme on this slide. And you can see here, basically the ledger there could be two types of ledgers. It could be a public type ledger or a private type ledger. Public type meaning everyone can see what's on the ledger, and private meaning only select, you can say members, only visible to members. And the consensus protocol typically involves validators, and these validators could be an open group, meaning anyone can be a validator on this network. When we say anyone, we are referring to nodes on the network. And then a closed group, the validators are basically selected by a governance model. It'll be a select group of validators, validator nodes. Now, using these four concepts like open group, closed group validators, public and private type ledgers, we can, understand these three different architectures. The public permissionless type is basically a public ledger with open group validators. And then the public permissioned is basically a public ledger with closed group validators. And then finally, we have the private type, which is basically a ledger that is maintained by a group, and also validators are also a closed group or a select group of validators. So we have three different architectures. So the first two are typically referred to as public blockchains. As you can see, the term public in both cases, like public permissionless, public permission, they both are, they both fall under the category of public blockchains. And the last one, the third one you see, is a private ledger, a private blockchain, I should say. It could be a DLT as well. So these are used in enterprises and government use cases. Now, expanding on the architecture we talked about, so we could have, for example, a virtual machine. In the case of like Ethereum, there's a virtual machine, and it enables deployment of smart contracts, and so we can have applications running on that virtual machine, which basically enabled a launch of several applications shown here, like it could be a wallet, payment service, exchanges, stable coins, fundraising platforms, could be DeFi, DAOs, NFTs, games, Metaverse as well. So we will look at some of the examples of these applications in the next few slides. Now, that was about blockchain. Now, let's also look at Web3. What does Web3 mean? So Web3, before we talk about Web3, let's look at the history of the evolution of the term, starting with the launch of World Wide Web and back in 1989 by Tim Berners-Lee at CERN. And then around 1.0, the web, around 1989, Web 1.0 was launched, where like Netscape and Internet Explorer and Mosaic were launched, and that basically started the internet revolution. And around 2004, to up to now, there were many platforms where there were like a lot of user-generated content, like Wikipedia and social media, blogs and networking services, and so on. And in around 2014, Gavin Wood, one of the co-founders of Ethereum and founder of Polkadot, proposed the term Web3, basically referring to web utilizing blockchain technologies and token-based economics. And in 2022, Tim Berners-Lee, the same person who invented the web, coined the term Web 3.0, basically referring to user-controlled data, meaning the users basically control and own the data. So there are also two other terms that are not really used, they're not that popular, like Web 4.0, Web 5, and so on. But just to let's look at some more details about Web 3. What does Web 3 mean? Like Web 3 actually is a confusing term. Especially in the crypto community, they tend to add everything that happens in the crypto community. They add to this bucket, cryptocurrencies, DeFi, DAO, NFTs, games, Metaverse, and then also some of the features they talk about are decentralization, ownership of data, assets like NFTs, privacy, data protection. So you see a whole bunch of things that are all clubbed into this the Web3 term, and nobody really actually defined what it is. So it's kind of a vague term used by primarily by the crypto blockchain community. Now, this slide shows the opinions. There are different opinions about Web3 and Web 3.0 in the sense like you have this on the left side, you see the blockchain community talking about Web3 enabling the next generation of the internet, a decentralized internet. And on the right side, you can see Tim Berners-Lee talking about how blockchain not a viable technology for the next generation of the internet, and he has his own ideas of what it would be, and he calls it Web 3.0. Really, I mean, if you look at the heading, it's like it looks very. The only difference is looks like .o, but however, the philosophical differences are huge. But there is one common theme between these two communities. It's the user ownership of the data is a common, common theme between these two communities. Okay, now let's look at what's happening in the public blockchain space. Let me go back to show you what we are talking about. It's basically the public permissionless type and public permission. We refer as public blockchains, and we won't spend much time on the private blockchain today. So now let's look at public blockchains. So public blockchains, you can see here, there's a whole list of public blockchains out there like Ethereum, Cardano, Polkadot, Solana, and so on. On top of these, each one has its own ecosystem. Like basically, you can deploy your smart contract on any of these public blockchains, and you can, and if you look at the category based on the market capitalization, cryptocurrencies and the blockchains DLTs, their market caps are shown here and primarily driven by speculation. Cryptocurrencies don't, really have a use case other than being used for transfer of, whatever the currency that it is, cryptocurrency it is. And blockchain and DLTs, we're referring to programmable chains where you can deploy applications like the ones you see on here, like DeFi, GameFi, NFT. They're all deployed on public blockchains, like the ones we see here in this infrastructure projects here. So even as of today, it's still like the cryptocurrencies and the value of cryptocurrencies, we can call it the market cap of cryptocurrencies, and the blockchains and DLTs are all primarily driven by speculation. The actual applications are not that many. You can look at the applications like stablecoin, maybe the biggest use case as of now. The other ones are relatively small compared to the market cap of the cryptocurrencies or even blockchains itself. So, as I said, stablecoin is the biggest use case of on a public blockchain, and as you can see, there are multiple stablecoins out there, and the biggest one is Tether with almost like $100 billion of market cap. And stablecoins are basically a smart contract deployed on a public blockchain, and they're supposed to, the value of that is supposed to be a dollar. Uh, and these stablecoin issuers are supposed to have this market cap or assets backing this market cap in a bank account or a custody, some sort of investment that backs the value of the market cap, and that's why it's called a stable coin, meaning the value of the price of the stable coin is backed by the assets in the held by these companies that are issuing the stable coins. And you can see on the right, it's almost 140, even 150 billion market cap, which is, if I go back to the previous slide, you can see which is the number one use case or number one application running on a public chain. And DeFi is another use case. Decentralized finance basically refers to, like borrowing and lending in the crypto space. Let me talk about an example. Like, let's say you have an asset in the real world, like gold, or it could be house, or even a car. You can actually, take those assets to a bank and borrow money. So this is the, what we know in the real world, traditional finance, borrowing, lending. You can also lend money to somebody, you can borrow, right? So if you have crypto assets, let's say you hold Bitcoin or it could be Ethereum, and now you could actually borrow money against the Bitcoin or Ethereum, just like you would borrow money from a bank, with your gold or a car or a house, right? So here, the assets are crypto assets, and you're borrowing money also in crypto. It could be a stable coin. Let's say you have one Bitcoin, which is, let's say today is about 60,000, and you could borrow maybe up to 50% or 60% of the value. Let's say $30,000, which is 50% of the value of the Bitcoin. And it's all the borrowing. Who does it? It's actually a protocol. You basically, you know, you use the protocol to do this lending and borrowing, and that's what this is. You can see there's staking, lending, there's exchanges, bridges, all kinds of use cases. And the DeFi land, total DeFi, the total value locked, TVL, in various DeFi protocols add up to around maybe 100 some billion, which could be the second use case of public blockchains. Now, NFTs are another use case or applications, and there are multiple projects you can see here. I list only the top 10 here, and one of the popular projects is called Bored Ape Yacht Club, BAYC, and you can see there was a lot of speculation around 2021 and 2022. And but right now the price of these NFTs are, it's very low, very low. I think it's the lowest point since the 2021 peak values here. Now, some of the big brands also started exploring NFTs. In fact, recently the USPTO issued some guidance on, copywriting, trademarking, and patents based on NFTs, and so it's slowly becoming a mainstream with the adoption of big brands, and also, some governments are also looking at using NFTs for identity and so on. Okay, this is another use case, gamify. If we had it on that graph we had on the use cases, right? So in the case of gamify, basically these games have some tokens, And when you play those games, you could get rewarded in terms of the tokens. So that's why it's called play to earn. So when you play, you earn some tokens, and the number of users are still not that high compared to some of the popular games out there. But this is an interesting concept, and there's hundreds of games that are based on blockchain uh, technology. Specifically, they issue tokens, on could be on Ethereum or one of the public chains. And also, some of these games use NFTs. We'll talk about that shortly about NFTs. Okay, now let's talk about Metaverse. And we talked about blockchain, Web 3.0, and now let's spend some time about Metaverse. So Metaverse, there are two types of communities building metaverses. The one on the left, you see, we call them blockchain based or so-called decentralized metaverses that are built using, you know, blockchain technologies, specifically like, they would have a token as well as some NFTs, like, Sandbox, Decentraland, Upland. These are some of the examples. As an example, like Upland, the game here, they try to create a virtual copy of, for example, it could be a New York City, right? They would create a virtual copy of New York City, like Times Square and all these things. They would be represented as NFTs, and you can buy those NFTs in those games. And on the right side, you see um, centralized metaverses by Roblox, and you have Second Life, you have Meta, and so on. Now also with the launch of Apple Vision Pro, so these metaverses typically require a headset, and also they are specific to their software. For example, if you buy a Meta, and usually, you can only run Meta's Horizon Worlds content, and similarly with many of these metaverses on the right side. So we have two communities. We can think of it as like left side is blockchain community, blockchain based community, and the right side is like just the Web 2. We can call Web 2 companies getting into the space, or Web 2 or even gaming companies like Roblox, right? It's a gaming company. And if you look at the number of users, basically we have the left side and the right side, we have the numbers for those two communities, and obviously, Upland has 3 million users, still not as big as you see on the right side, like Xbox and Meta and all these Roblox. They're talking about hundreds or 200 million users. So the adoption of blockchain-based metaverses, is still low compared to these the right side companies. So, like I talked about earlier, I'm going to spend some time to talk about how blockchain can enable metaverse. For example, like digital ownership, like, if you have, you can own assets in the, metaverse, like the one I talked about, Upland, where you can buy buildings, like the buildings you see on the right side. You can actually, these are represented as NFTs, so you can buy those NFTs, and you can buy land, avatars, and all kinds of artifacts, and you can own them. And some of them don't require headsets, like the one we talked about earlier, like Meta and Apple Vision Pro. And these metaverses, you can actually play the games on a phone or a laptop. Okay, so this slide shows, how blockchain could be used for proof of authentication, or I should say authentication. So now with the rise of Gen AI, right, there's so much you can create, text, video, audio, coding, images, and so on. So there is going to be a lot of fake content. I'm sure you heard about deep fake videos. So now authentication is critical for identifying the original content and certifying the real owners. So again, here blockchain technology could be used for storing the proof of authentication. Example, it could be an NFT. The another topic where blockchain could be used is in terms of bringing reputation and trust to metaverse. See, in the if you look at what happened in the Web 2 space, even Web 1 space, primarily Web 2, like we have Amazon and all these platforms where you could, well, basically we choose to buy a product based on the number of reviews and ratings, the rating system. So we typically go with a product which has the highest rating and highest number of reviews. So this is how the entire basically statistical trust based on statistics here. Now we need a trust system, um, reputation and trust model for metaverse because there's going to be a lot of users are pseudonymous, and reputation is critical for interacting with them, for even transacting with them. And this is where blockchain could be used for creating an on-chain transparent reputation system. Okay, so this slide shows the scenario where users may have assets in Metaverse One, and they may want to move their assets to another metaverse, like from Metaverse One to Metaverse Two. That's transfer. Also, they may have assets in multiple metaverses, and they want to be able to, like map those into one identity that they have, instead of creating multiple identities. Remember, a few years ago, we have to have like login and password. I think we still do for many websites. Every website you would have to create login credentials, and now lately, depending on where you are, and if you're in the US or Europe, it's if you're using an Apple phone, then you can do Apple sign in, or it could be a Facebook sign in, it could be a Google sign in, and they give you these options, right? Now it's becoming like these few handful of companies managing the credentials. So in the case of metaverse, the idea is to be, well, there's a concept of decentralized identity, which is actually the next topic I have, where you could have an identity on blockchain, which would basically connect all these different metaverses or your avatars in different metaverses, as well as assets. You may have assets in multiple metaverses, and all these things could be connected mapped to your identity on blockchain. And one is of course mapping, connecting the assets and identity, but there are also scenarios, you see some example scenarios where you may want to move the assets from one metaverse to another metaverse, or it could be within the same metaverse. That's intra interoperability scenario. But if you want to move, let's say, between two different metaverses, then there's you have assets in Metaverse One and Metaverse Two, and you want to move all your assets from Metaverse One to Metaverse Two. That would be interoperability, same user, different metaverse scenario. And then the last one, you have different users and different metaverses, right? They're possibly like transacting with each other. And I did mention about the decentralized identity. There's almost over 66 projects and tools based on blockchain technology. So we did talk about this. Uh, let me actually bring up this article that I wrote. It's been a couple of years. It's actually, yeah, 2022 October, but it's still relevant. I mean, a lot of the stuff I talked about in this article are still relevant. So I encourage you to check out this article published in the November-December 2022 IEEE Potentials. And that's just my background. You know, you can connect with me on LinkedIn. That's the QR code for my LinkedIn. And again, thank you. Here is the the QR code on the website for the blockchain technical community. And if I do have a backup slide, I could spend a minute or two to talk about Bitcoin, because typically people always ask about the energy consumption of Bitcoin. So Bitcoin, if I go here, let's go all the way to the energy consumption. So here is a graph that shows the energy consumption, annual energy consumption of Bitcoin network. It uses proof of work. As a result, there's a lot of computations, which leads to, we call it hash rate, which leads to a lot of energy consumption. You can see here it's was 176 terawatt hour per year, which is comparable to some of the countries like Egypt and South Africa. That's the whole country consuming this much power for the whole year, and Bitcoin network is comparable to these countries, and it's keep going up. And this has been a big concern in the uh, Bitcoin community in general, and blockchain. When people talk about blockchain, I always get questions about the Bitcoin energy consumption. Let me stop here and see if there are any questions, comments. Yeah.
Okay, thanks for the Ramesh. Thanks for your very impressive talk. Yeah, actually, I'm not very familiar with this the blockchain, metaverse, this kind of the details. But through your presentation, I think it make me realize more and more details of the of these new items. Yeah, yeah. It's very impressive. Yeah, it's a very impressive introduction to this. Yeah, and also I see you are involved. Kind of deeply in the IEEE standards. Or some societies and technical committees, and that's also very awesome. Yeah. So let's see if the tennis or the audience have any questions. If you have any questions to the presentation, you can raise your hand and then speak directly. Anyone has the question? Okay, so basically let me ask you one question. So actually from your presentation, I think I have a concern is that I mean that how might be the metaverse involve in the upcoming years? I mean that how might metaverse shape the future of the human interaction and culture? And also, when do you think it could be realized in our real life? Yeah.
Well, metaverse. When we talk about metaverse, right? There are many use cases of
Mm-hmm.
metaverse. Education, learning
Mm-hmm.
is one fast emerging area. And then also, like, we have industrial metaverse, where companies are using metaverse for improving their manufacturing. For example, I'm still in Germany, Munich, which Siemens invested like $1 billion into industrial metaverse. So they're looking at how to improve the
Mm-hmm.
operations and manufacturing and supply chain, and even training, like technicians, upskilling, retraining, So this is industrial metaverse, and you have also the consumer metaverse, which is typically what people talk about, like gaming and also like entertainment, right? So these are consumer metaverse. So there are different use cases of metaverse. Like as I said, education, there's consumer, then there's enterprise. Well, you can also industrial metaverse. So each one
Mm-hmm.
is evolving at an interesting pace. For example, as I said, Germany is big into manufacturing, so they're looking at industrial metaverse. But in Asia, like entertainment is big, so there's a lot of consumer metaverse stuff happening there in India and China, and education is happening, I think, everywhere. In fact, I was at an event last night here in Germany, and they are you know talking about educating like school kids on metaverse.
Mm-hmm. Okay, thanks for your question. Another question is that I mean that to achieve the metaverse, I mean, what kind of technology, wireless, because I'm working on wireless communications like 6G communication. I think
Mhm.
from your perspective, what kind of wireless technology or what kind of network infrastructure are needed to support the metaverse, particularly the large scale virtual world. Yeah.
Yeah, that's a good question because there's going to be a lot of 3D objects, rendered objects, and now you have to worry about storage and also the communication, right? Because if you don't have good internet, then it's going to be hard to use metaverse. I mean, just like Zoom, right? If you don't have a good Zoom, I mean, good internet, you can't really do a Zoom call,
Mm-hmm.
right? If somebody, so same with metaverse, it's the internet connectivity is very critical, and also of course now the start the we talk about 6G and all that, right? And well, communication is just one part of it, right? But as I mentioned earlier, there's going to be storage. It's going to be a big issue. You have to store a lot of these the objects created for different metaverses, and yeah, I mean, already there's an issue with data storage, right? I mean, there's a technical, there are multiple issues that are being discussed in the space, right? You have the technical issues, like, you're just talking about, connectivity and computing and storage and so on. And there are all the issues like social issues as well, like, societal issues like safety, ethics, and also privacy of data. So there are also social issues as well. So that's why, in fact, this Monday, I'm going to Brussels, Belgium, where we have, you know, we're organizing a meeting to discuss about what kind of policies we need for, before metaverse goes into mainstream.
Mm-hmm. Okay. Okay. Thanks for your answers. Okay. So I think maybe in the future, because just now you mentioned that in Shanghai we have the blockchain chapter, right? This kind of
Yeah,
stuff.
there's a blockchain group. Yes, I would be happy to
Yeah,
connect you
I
with
think that do you know who is the organizer? I think that
Professor
guy is
Edward.
my friend in
Professor
Tongji
Edward.
University.
Yes, correct. Tongji University.
Yeah, yeah. Because the last time I received his email to talk about this. Yeah, he said
Yeah,
he established the something about blockchain. You know,
yeah.
yeah. Okay, I think maybe if you and him organize the activity next time, maybe in Shanghai, I can join in. Yeah, you
Yeah,
can
definitely.
meet
Just
in
ping
person
me
and have a
your email
yeah
address. I'll
tip this.
keep you in the loop.
Okay, okay, that's for sure. Yeah, thanks. So, any questions from the attendees? I saw there are several attendees. Jay Lee, do you have any question? Or Junjie, if you have any question, you can speak directly. maybe I think you can raise your hand and I can unmute for you. Okay, if you don't have the questions online, maybe if any of you have any questions, you can contact Ramesh, Dr. Ramesh, and in the offline. And also, you can watch our video online in the YouTube later. So again, okay, Ramesh provided a lot of information about himself and also the QR code. You can also scan the QR code. So, okay, thanks again, Ramesh. Thanks again for
Yeah.
your nice presentation. Okay, I look
Thank you.
forward to see you in the future. Yeah.
Yeah,
Okay.
same here. Thank you. Thanks for
Okay,
hosting.
that's the end of this talk. Yeah, okay, thank you.
Thank you. Bye-bye.
Bye.